Hello everyone, this is Kanish Khandelwal and this is fourth video from our series Data Science with Python, and this video contains data preparation phase to model the data. So let's get clear about this. So in our previous video we have created the data, we have indexed it properly, we have seen it from graphs and everything. So in today's video we are doing the setup phase. So this contains four major topics: partitioning the data, validating the data partition, balancing the data, and also the decision trees from CART and C 5.0. So let's get to a second slide. Partitioning the data. So the training set records are complete, but the test set records should have the target variable temporarily omitted. So the data science model learn about the patterns and trends in the data using training data sets. So these models are applied to the test where they make predictions for the temporarily unknown values of the target variable. The size of the partition differs depending on the size complexity for highly complex data sets, where, for example, a neural network model needs to learn about many non-linear reactions within data. More training records would be required, would be recommended, say 75 to 90% of the original data. In addition, if the data set is very large, it is convenient to have more records in your training set. On the other hand, for smaller or less complex data sets, one should retain sufficient records for accurate assessment so that training data sets would contain only 60 to 67% of the original data. So let's go to the Spider compiler where we will apply this. So in previous video, I have shown you about the compiler and the things which I am using. So I have wrote the code already. I will run this libraries which are required. First is Panda. So let's run these. I have run already these libraries which will be required. These are the libraries that consist of different sets of methods which will be required in further program. The second we are importing second is importing from sklearn. So from this we are importing the train test split. The next is we have to take our data from the file to a variable. So the variable here is bank. Then we are splitting the data using test underscore split. This is a inbuilt function from sklearn dot model underscore selection library. So when I will run this particular code, this will split the training data and the test size will be 0.25. Random state is 7 and bank is the variable which consists the data. So the next thing is we will count the value from the column loan. So this will give us that we have two 28,515 values which says no, and 53,000 5,394 yes. So we have calculated from this that our data set should contain approximately 30% of yes. So through this, till now we have splitted the data. From this step, we are from this step. Let's go back to the slides. We have partitioned the data. So the next step is validating our partition. So we are validating our partition. So for this, I am using basic Python code, which says that the counts we have got from yes are used to split it more and validating our partition. The next step is balancing our training data set. So in some classification models, one of the target variable classes has a much lower relative frequency than the other classes. In such cases, balancing the training data set may be recommended. So for balancing, we have counted the yes and no's. So the yes and no's are the records, and we have created 25% from the data. So so we will calculate that we want 30% of the response to be yes. So 0.3 into records count minus 338, which are rare records, divided by 0.3 minus 1 mod, which is 0.7. So this is this is how we will do this in Python. This code will do this same work as I told earlier. So this will create the resample, and when will when I will type n, the n is 6826. So this is our new values, and this much yes we will get in our training data set. So we will resample this our training data set in terms of our new value of n. First we have to give two resample. So to resample, we will give LOC method. This LOC method will locate the yes count from lone column, and then we will resample this with the n value. So a new variable bank underscore train underscore rebel. This will concatenate our sample data to our sample data set. So this is how we will balance our training data set. Now we will go to the next topic. We will make CRT decision trees and C 5.2 decision trees. Decision trees, we have set up the phase. We are ready to finally begin modeling our data. In the modeling phase, data science offers a wide variety of methods and algorithms for modeling large data sets. We begin here with one of the simplest methods, decision trees. So in this topic, we'll work with this data set in form of income and everything. So this decision tree data, here it is. So I'm importing Panda is already imported. So I'm importing NumPy, and I'm importing a new data set called adult underscore TR. So adult underscore TR is a training data set which I have considered. So let's look at the data set. This is the training data set which I am considering here for a decision tree. So let's go back to the Python. So we will load this data set in our program. Then we will load the sklearn.tree. This will be used for making decision trees. Then we will load income column from this training data set. So this is done. Then we are calculating array. We are getting an array. So this array will have the marital status columns, different values. So here in marital status column we have three values: divorced, single, or married. So this array is here. Let's get. Let me show you the data which this is carrying. Yes, so widowed, married, civic spouse, and many more. These are data types this uh, array is carrying. Now the next step is to categorize this data. So when we will categorize that, and the next step is to get this data into a dictionary. So we will get a dictionary for this categorized data of marital status. Let me show you this dictionary. Yes, so zero is the number is given to divorced, a spouse, civilian spouse, and many more. There are basically six categories which are given in our data set. So we got this. Now we will concatenate this, as you can see that we have dictionary about this data. Now we will make a data frame. Next step will be about capital loss column. Then we will get the dot dummies function used to get the dummies about true values, the upper variable x, which has the capital loss. So let's run this. And then we will name the columns that we are using and other things. Then y name stores the first variable which will differentiate in our decision tree. So let's run this, and tree equals to decision tree. So this will get us a decision tree. Let me check why it's giving an error. Yes, so this complete is a single line of code. Let me run this now. The numbers are not matching. Let's check it out again. Number of layers does not match the number of samples. Let us check again. This is showing in some error, but let me show you the output of this program. So the output of this program will be this right one, this decision tree, which is showing the decision tree, CART decision tree it is. So this is it for this video. Thanks for watching.